So now we'll start with the chapter that is statistics of 10th class. So as we have already studied statistics in 8th class, 7th class and 9th class, and now we'll study the statistics in depth, and will accordingly start with mean, median and mode. So first we'll read about mean. As we already know about mean, that mean is actually we know how to find out the mean. So mean is actually one of the method to find out the average of the given data. And how to find out the mean is, to find the mean we'll use the formula, or we'll use the method that is sum of all observations divided by number of observations. That is, whatever observations are given, what we can do is we'll add those observations. So accordingly we'll get the sum of all observations and divided by the number of observations that is given. So if we take if we divide this sum with the number of observations, so accordingly we'll get the mean. Like suppose if I take any example, 2, 3, 5, 9, 11. Let's say I have taken these 5 numbers, and if I need to find out the mean of these 5 numbers, so accordingly mean is equal to sum of all observations, that is 2 plus 3 plus 5 plus 9 plus 11 divided by number of observations, that is equal to 5. So this 2 plus 3 plus 5 plus 9 plus 11, if we add all this number, accordingly we'll get as if you see 2 plus 3 plus 5, it is 10, 10 plus 20, that is 30 divided by number of observations 5. So mean accordingly will get as 6. So this is the method of finding out the mean that we have already studied and we know. But there are some things. So this is the method we use when we actually need to find out the mean of the given data, or if the data is in the if the random data is given, like if you have taken this data as 2, 3, 5, 9, 11. So we have taken this random data, and accordingly we have find out the mean by adding this all observations, or adding this data divided by the number of observations given. So this is the method of finding out the mean. But there are some cases in which you will get the frequency distribution table. This is the data. If you get the direct data, this is the method of finding out the mean. But if the frequency distribution table is given, let's take example of frequency distribution table. As we already know, what do you mean by frequency distribution table? So if the frequency distribution table is given, and in the frequency distribution table accordingly two types of data can be find out, or two types of frequency distribution table can be made. One is discrete frequency distribution table, and another one is continuous or group frequency distribution table. We have already discussed about both this table in 9th class. Now we'll see how to find out the mean when the discrete frequency distribution table is given. So that is discrete frequency distribution table. So if the discrete frequency distribution table is given, then how to find out the mean is, first we'll take some example. So accordingly we'll take some frequencies and the observations. So let's take observation as x and frequencies as f. So accordingly we'll take some observations as let's say 1, 2, 3, 4, 5. Now accordingly we'll take frequencies as let's take 50, 40, 30, 20, and let's take 10. So this if you observe this table, what is given, that there is one observation which is equal to 1, and frequency of that observation is 50. It means that observation is getting repeated 50 times. There is one observation 2 whose frequency is 40, means that observation 2 is getting repeated 40 times. In the same way, the table is given. And if we need to find out the mean of this discrete frequency distribution table or discrete frequency data, then what we can do is, we first need to find out the f into x. F into x is what we need to do is, we'll first have to multiply this x and f. So accordingly we'll get f into x. And why we are finding f into x is because we need to find out the sum of all observations. So as the observation 1 is getting repeated 50 times, it means we need to add 150 times. So it means what we are doing, 1 into 50, that is 50. In the same way, 2 is getting repeated 40 times. It means we need to add 2 40 times. So what we can do is 2 into 40, that is 80. Accordingly, 3 into 30 equal to 90. 4 into 20 accordingly we get as 80, and 5 into 10 accordingly we get as 50. So if we add all this, that is, if we get the sum of f into x, so actually this will give us the sum of all observations. So if we add all this f into x, so accordingly what we'll get as 50 plus 80 plus 90 plus 80 plus 50. So accordingly what we'll get if we add all these things as 350. So this we got as the sum of all observations. It means if we add all the observations, we'll get as 350. So accordingly we use the same formula for finding out the mean, that is sum of all observations, that is summation of f into x. This will give us the sum of all observations, as we have already discussed, and number of observations we got from if we add all the frequencies, because frequencies is telling us how many observations of each type are there. That is, one observation is 50 times 2 is 40, 3 is 30, 4 is 20, and 5 is 10. It means it is giving us the information, that is which observation is getting repeated how many times. So accordingly, if we add all the frequencies, we'll get the total number of observations. That means if we add 50 plus 40 plus 30 plus 20 plus 10, we'll get the number of observations. So if we add it, what we'll get is 150. So this we got the sum of f. So accordingly, the sum of f into x is 350, and sum of f is we are getting as 150. So now if we divide it, we'll get the value of mean. So for dividing it, what we can do, we can cancel out 0. So accordingly, we'll get as 35 by 15 or 7 by 3. So 7 by 3. So if we take it in the decimal form, we can also write in decimal form as 2.33 approximately. So this approximately will get the mean. So this is the way to finding out the mean when the frequency distribution table is given. So this is the method. So again we are using the same formula, that is sum of observations divided by number of observations. But that formula is we are writing out in a different manner. That is summation of f into x divided by summation of f, which is actually giving us the sum of observations divided by number of observations. So this is the method of finding out the mean. So in this way we can find out the mean when the discrete frequency distribution table is given. But let's say if the continuous frequency distribution table is given, then there is also the method we have studied. But this is the one method that we have studied in the discrete frequency distribution table, and this method that we have studied is actually known as the direct method. Direct method, because in this directly we have taken the summation of fx and summation of f, and accordingly we have find out the mean. This method is known as the direct method. Apart from this method, there are two other methods for finding out the mean when the discrete frequency distribution table is given. And the second method for finding out the mean in the discrete frequency distribution table is deviation method, or it can also be said as assumed mean method, or shortcut method. So this is the other method of finding out the mean when the discrete frequency distribution table is given. So how to find out the mean by this method is actually when whatever the data is given. See, in the last question we have solved the question in which the data is given is little bit large, and accordingly we have done the calculation and find out the mean. But if the data is much more larger than this particular data which we have taken as example in the case of direct method. So if the data is much more larger than this, then there is a method of finding out the mean by which we can reduce the calculation, and that according to that method what we can do is we'll again take the same example and we'll solve the same example by that method. Is let's first write down the example as accordingly we have taken the observations and frequencies. Observations we have taken as 1, 2, 3, 4 and 5, and frequencies we have taken as 50, 40, 30, 20 and 10. So now, as if we want to reduce the calculation here also, so accordingly what we can do is we first assumed mean, or what we can do is what we need to do is we will assume one of the value of the observations. So accordingly, if we assumed one of the value of the observations, so accordingly what we can do is, like suppose if we have assumed the value or we have taken the assumed the value of the observation, or we have taken the assumed mean. So if you have suppose we have taken the assumed mean as, let's take 3, because 3 is the middle value, so accordingly we have taken assumed mean as 3. So this is the approximate value we have taken. You can take any value. It's not necessary that you can take the value among the given observations. You can take any value apart from the given observations also. So accordingly we have taken assumed mean as 3. So now what we can do is, we first what we can do, we'll first find out the d1 or di, and di will be taken as the deviation. Di will be taken as the deviation, or you can say the value which we'll get from the assumed mean. So what will be the use of deviation is, what we can do now is we'll subtract this assumed mean from each one of the observations. That is, what we can do is, for finding out the value of di, what we can do is we subtract this assumed mean from each of the observation. That is what we can do. We'll find out the xi minus a, and xi is the of different observations we can take, and we'll subtract this assumed mean from each of that observation. So it means if we take the first observation as 1, so what we can do, 1 minus assumed mean is 3, so accordingly we will get value of d as minus 2 in first case. Second case, 2 minus 3, so accordingly we will get minus 1. 3 minus 3, accordingly we will get 0. Then accordingly 4 minus 3 will get 1, and 5 minus 3 will get 2. So this is the value we got, that is the deviation. And now what we can do is we will find out the value of we find out the value of fi di. It means what we can do is we will multiply this deviation with the frequencies given for the particular observations. Like for the observation 1, frequency is given as 50. So we will multiply this 50 with the deviation of this, observation, that is minus 2. It means we multiply this 50 with minus 2 and we'll get the value of fi and di for all the observations. 50 into minus 2 will get as minus 100. 40, in the same way we'll multiply this 40 with minus 1. So accordingly we'll get minus 40, and then the same way 30 with 0 will get 0, 20 with 1 will get 20, and 10 with 2 will get 20. And now we'll do the summation of this fi di, or what we'll do, we'll add up all this observation, all this value of fi di we got. So if we add all this value, what we'll get as, we'll get the answer as minus 100. So as we got this fi di is minus 100, and now what we can do is, for finding out the mean, what we can do is we'll take this summation of fi di and divided it by summation of fi, that is the number of observations. But in this we also add the assumed mean that we have taken, because as we have subtracted the assumed mean from each of the observation, definitely we need to add this for finding out the mean of all this observation. So in this way we can actually find out the mean. So as we have already find out the summation of fi di as minus 100 divided by summation of fi. So accordingly now we'll take the summation of these frequencies, and the summation of frequencies we were getting as 150. So what we can do here is we'll divide it by 150, and accordingly we'll add the assumed mean that we have taken as 3. So now if we solve it, what we'll get as 3 minus 100 by 50. So accordingly we'll get as 2 by 3. And now if we solve it, what we'll get as 7 by 3, or 2.33 approximately. So it means again we got the same answer. So this is the method of finding out the mean. It means if we want to reduce the calculation of the table or the data given, so if you want to reduce the calculation, you can actually, what we can do, you can actually uh, take the smaller values and do the calculation like we have done in the assumed mean method. So accordingly, we have reduced the calculation by taking this assumed mean and subtracting it from the original observation. So accordingly, the value of fi di we get is actually in the form of negative and positive values, and when we have added it, we got the smaller value. We got the smaller value, that is minus 100, and when we have divided it by 150, we'll get, our calculation will get reduced by, when our calculation had get reduced accordingly, because in this what we are doing is we were actually dividing the 350 by 150, and accordingly we were finding out the mean. But here we are actually dividing this 100 by 150, and easier to divide this 100 by 150 than dividing 350 by 150. And for finding out the 350, for getting the value 350 also, what we were doing is we were multiplying these bigger values of f and x, and accordingly we were adding it, then we were getting 350. But here we have reduced the this value of these observations and got the smaller value of observations in the form of di, and when we have multiplied it by frequencies, we'll get the smaller values as compared to the direct method, and by adding it also we got the smaller value as minus 100 as compared to 350 in the direct method. So by this method you can also reduce the calculation, and accordingly you will get the answer much faster and accurate. So this is the method of finding out the mean in the assumed mean method, or the deviation method, or the shortcut method. So now we'll see one more example based on this. Let's take the frequency distribution table, which is having the observational frequencies as 67, 70, 72, 73, 75, and accordingly frequencies are 4, 3, 2, 2, 1. So accordingly we have taken this observational frequency. Now as you are seeing here that observations are very large. So if you use the direct method here, that is if you do the x into f. So for doing the x into f, what you need to do is you need to multiply 67 with 4, 70 with 3, 72 with 2, 73 with 2. So that will increase your calculation. So apart from increasing the calculation and finding out the mean, it is easier to use the deviation method or assumed mean method here. So let's take the assumed mean here as 72, as 72 is the middle value among these 5 observations, so we have taken it 72. It is not compulsory that you need to take this assumed mean from the given observation. You can take any value, like if I take 71, that will also be okay. So as I have taken assumed mean as 72, now what I can do is I will first find out the di, and di is actually xi minus assumed mean. So di, so accordingly di is xi minus assumed mean. So xi is 67 and assumed mean I have taken as 72. So it will become minus 5. Now 70 minus 72, it will become minus 2. 72 minus 72, it will become 0. 73 minus 72, it will become 1. And 75 minus 72, it will become 3. So this value I have got of di, and accordingly now what I can do is I will find out the value of fi di. So fi di means this frequency with, I will multiply it with deviation, that is 4 into minus 5. So I will get minus 20. 3 into minus 2, I will get minus 6, 0, 2 and 3. And now what I will do, I will do the summation of this fi di, and as I will do the summation of this fi di, I will get the value as minus 21. And now for finding out the mean, what I can do is I will divide this summation of fi di by summation of frequencies, and I will add the assumed mean that I have taken to this value. So accordingly I will get the correct value of mean. So summation of fi di is minus 21, and summation of frequencies, it means we need to add these frequencies. So if I add these frequencies, what I will get, the value as 12. So minus 21 by 12 plus assumed mean I have taken as 72. So I will add 72 here. So minus 21 by 12. If I find out the value of minus 21 by 12, I will get as minus 1.75 plus 72. So 72 minus 1.75 is 70.25. So this is the mean I got from the given observations. So this is the method of finding out the mean. By reducing your calculation also you can find out the mean, because if you are subtracting assumed mean from each of the observations, definitely you need to add that assumed mean to the final calculation, that is summation of FITI divided by summation of FI, and that what we are doing, and accordingly we are finding out the mean. And if you use a direct method also here also, then also again you will get the same answer of the question, or say you will get the same mean as 70.25. So it is easier for us to find out the mean by this method, because we are reducing our calculation by large up to large extent, because 67 into 4, 70 into 3 is will get the very bigger values, and by adding all these values and dividing it by the frequencies, that is 12, it actually increase the calculation by up to by large amount. So for for reducing the calculation, we are actually using this method, that is direct method. We are using this method, that is deviation method, shortcut method, or assumed mean method.